Good morning, friends. This is Nazir Ahmed from Triple E Final Year. I am going to explain slip power recovery schemes in induction motor. First of all, let us start with basics. What is an induction motor? Induction motor is a device which converts electrical energy into mechanical energy, and it works on the principle of electromagnetic induction, and it has much advantages, so it is mainly used in industry. Inexpensive, simple design, easy to maintain. The parts of an AC motor are stator, which is a stationary part, and rotor, which is a rotating part, and bearing for the shaft, and cooling fan to balance the heat, and frame and end bracket. Let us see the induction motor basic working in this video.
Three-phase induction motors are the most commonly used AC motors. With its ability to produce high torque with simple construction, relative low cost, and robustness, this motor gets high popularity. The basis for this induction motor is the RMF, which is built in the stator. How RMF is built was explained in another video. Please check out our playlist. The rotor, the moving part of the machine, exists of conducting bars with end caps on each side. That's why he has the appearance of a squirrel cage. Therefore, these motors are also named as squirrel cage motor. As the stator magnetic field rotates, voltage is induced within the bars of the rotor. As the rotor bars are shortened at both ends, there is a closed path for the flow of current. This, in turn, produces its own magnetic field in the rotor bars, which opposes the magnetic field of the stator. The direction of the force, as a result of the interaction between stator and rotor field, can also be determined by the Lorentz law. Torque can only be created when rotor current is induced. To say it in another word, the rotor always has a rotating speed, minor to the RMF. This difference is called slip. To enhance the magnetic field of the rotor, and therefore the torque, the rotor bars are mounted within a pack of steel laminations.
We all see the induction motor working in the last animation video. It will helpful to understand the remaining slides. What is the slip of an induction motor? Slip means nothing but it is the ratio of relative speed to the synchronous speed. What is the synchronous speed? Synchronous speed means nothing but it is a theoretical speed when the motor rotor speed and the stator voltage and rotor induced voltage are same. The motor should spin. At that time one speed is produced. That speed is called synchronous speed. And this is the slips. Slip speed is nothing but synchronous speed, difference between synchronous speed and the speed in RPM. Let us start with slip power recovery scheme in induction motor. Before starting that, what is meant by slip power? Slip power means nothing but an air gap power which cannot be converted into mechanical power. Okay. Slip power is nothing but an air gap power which cannot be converted into mechanical power. That power can be recovered by following schemes, that is static Kramer drive, and the another one is static Scurbius drive. Instead of wasting the slip power in rotor circuit resistance, it is a better approach to convert it into AC power to return back to the line. Okay, then only we use these two schemes. Let us see. This schemes is used to control the speed of slip ring induction motor, and speed control of induction motor can obtain by either this method or either below or above or synchronous speed. Stator voltage control and rotor resistance control have poor efficiency at low speed range, suitable for limited applications. In order to improve the performance of the system, like efficiency and capacity of the drive, if the slip power of the SRIM can be returned to the supply systems, thus the overall efficiency can be used. So to increase the overall efficiency, this method can be employed. Slip power recovery schemes. First one is Kramer drive and the next one is Scurbius drive. and it is further classified into conventional slip power recovery scheme system and static slip power recovery system. Kramer slip power recovery system. This is used to control the speed of an induction motor below the rated speed, and it can be either by obtained by conventional or static. Conventional, we have conventional Kramer drive system and improved Kramer drive system and static Kramer drive system. We will see in block diagrams and circuit diagrams. This is the conventional Kramer system. This is the main rotor, and main rotor having mechanical coupling with a DC motor and then rotary converter and slip rings of an AC side rotor converter, and mechanical coupling and slip rings on AC rotary converter are interconnected. This is the DC supply to the rotary converter and DC motor, three-phase supply to the motor. This type consists of SRIM and DC motor and rotary converter. The slip ring of SRIM, slip ring induction motor, is connected to input of the rotary converter. Okay, it can this input is connected to slip ring is connected to input of the rotary converter. Okay, then it converted AC into DC voltage and fed to DC motor terminals. It converts AC into DC and fed to DC motor terminals. The DC motor shaft is connected with the shaft of the SRIM. The DC motor shaft is connected with the shaft of SRIM. The speed of SRIM is controlled by varying regulator of the DC motor. The speed can be varied by varying the regulator, and the field regulator is connected to separate DC bus. This type is also known as constant power control. Hence, the power factor of the system can be also improved. In this Kramer drive system, the power factor can also be improved. Next one is modified or improved Kramer system with the diode supply and DC motor. In between the motor circuit and DC motor circuit, a three-phase diode circuit is employed. With the thyristor means instead of diode we can have thyristor. Thyristor means we can when only we trigger the thyristor, then only the output you will get the output. In this system, the mechanical rotary converter is replaced by three-phase diode bridge rectifier. The slip power of the rotor is fed into the input of three-phase diode bridge rectifier. It converts AC into DC, and its ripple is filtered by series connected inductor. The filtered DC output voltage is fed DC motor armature terminals. The DC motor shaft is connected with the shaft of SRIM. The speed of SRIM is controlled by regulator of the DC motor. The field regulator is connected with separate DC bus. Okay, the control speed ranges 0 to around synchronous speed by varying the firing angle. If you vary the firing angle, the output will change according to the firing angle. The diode is replaced by SCR for high power applications only. Okay, static type Kramer slip power system. For this slip ring induction motor, and in between the motor circuit and slip ring induction motor, we have thyristor circuit and bridge rectifier and inverter bridge rectifier connecting the smoothing reactor. Okay, this type of system is very popular in large pump and fan drives. When range of speed control is limited near below synchronous speed, the drive system is efficient but power converter is very low. This system is also called constant torque drive. Advantages of this system: the system of speed control is economical, but because the rectifier and inverter only have to carry the slip power of the rotor, which is less than the input power to the stator, it is quite simple and stable. Main advantage is we can convert the air gap power into mechanical power. The if you don't convert the air gap power, it is going into losses. Okay, that losses can be retained by using these kind of static Kramer system, static conventional system, like that Kramer. Okay, these power recovery schemes can be used. This slip power recovery drives are used in the following applications. The main conclusion: what are the future scopes? Okay, future scopes in slip power recovery drives is large capacity pumps and fan drives, variable speed wind energy systems. In future, the electricity is going to be electric vehicle only, so we can save these kind of power. It will be useful for us. And shipboard VS VSCF, variable speed constant frequency systems, variable speed hydro pumps and generators, utility system, flywheel energy storage systems. These are the future scopes, and the main conclusion is we can convert the air gap power into useful mechanical power by using the following scheme, by using the Kramer systems. Okay, thank you for watching the video.